All right, today's lesson is over section 5.1, solving systems of equations by graphing, which is the third and final way that we're going to learn this year to solve a system of equations. So we are going to learn to graph them. Of course, you already know how to graph equations in slope-intercept form, and so that's really what we're doing today. In fact, you might remember the homework problem we had not so long ago with these airplanes and trying to figure out what the solution to the system of equations were as far as getting to the airport. And so we drew a line that connected this plane to that dot, and then we drew a line that connected this plane to that dot as well, because we knew they were both going to the airport. And then we calculated the slope and the y-intercept. It was a little bit easier to do the y-intercept for the blue line because it actually crossed somewhere nice down here. For the red line, we had to use the slope to figure out where it was. I believe it was 14 up here is where the y-intercept was. And then once we had those equations, we were actually done with the problem. That's all it wanted to know. And so you can see the solution to the problem actually would have been right here, the intersection point of where those lines meet. And that's kind of the whole idea of today's lesson, is we're going to graph lines, and the solution to our system of equations is going to be where the lines intersect. You might remember probably one of my favorite problems of the year when we talked about the popcorn bucket from the AMC theater, and we talked about what would it be a benefit to you to buy the popcorn bucket or to not buy the popcorn bucket. If you decide that you get popcorn every time, when does it become an advantage for you? So we actually said, well, if we just buy a large bag of popcorn every time we go, and that costs $10, then we did that in red, and we graphed that red line. And we said, well, if we buy the popcorn bucket and it costs $25 and then $5 to refill it, we graph that with the blue line, and then we found the intersection point was actually after 5 trips, the cost would be the same. And so it was kind of difficult to see if that was going to be 4 or 5. It's kind of hard to tell where obviously this is the intersection point. It was hard to tell exactly how many trips that was. And so what we did, and to answer this question here, what method did we use to solve? We actually used substitution. You may not recognize that, but we substituted 10x in for that y right there, and then we solved it and found out it was exactly 5 trips. And we were done. Now, if this was a regular system of equations, we would have said that we still needed to find the value of y, and so we would plug 5 in for either equation, probably the top equation right here, and then we'd say y is 50. And that's what we're going to be doing today. We're going to be finding what x is and then plugging it in to see what y is, or not even plugging it in. You can see that once we find the intersection point, it was right there at 50 all along on the y-axis. All right, so the steps for solving a system of equations by graphing. Number 1, we're going to write both equations in slope-intercept form. That's a must if you're going to graph them using slope-intercept form. Number 2, we're going to graph each line. Number 3, find the point of intersection. And then 4, we're going to write our answer as an ordered pair. All right, so for this first example here, example A, we've got a line that says y equals 2x plus 5. We know the b value, the y-intercept, is 5. And we know that the slope is 2, which means rise 2, run 1. Or we could even go down 2 over 1. Down 2 over 1, down 2 over 1. And then, so that's going to be our line going through the axis here. So that's our first one. And it's really important that you draw your line all the way through the graph, because the other line could intersect it at any spot. So we have to draw the line all the way through. And then our second line here, this one here, is going to have a y-intercept of -1, and it's going to have a slope of down 4 over 1. Or you could say up 4 and left 1. Up 4 and left 1. You can see where our point of intersection is going to be. Right here at 1 on the x-axis, or -1 actually on the x-axis, and 3 on the y-axis. And so that's our answer. X is -1 and y equals 3. For our second problem here, we can graph, again, the top line, I'll do in green. This is 3 for the y-intercept, and the slope is -1. So I'm going to put a point right here, and then I'm actually just going to put a bunch of points. I'm not using Notability right now to make this video, so I don't have the feature to be able to draw a straight line like you guys don't, so it's kind of real life for me. So I'm just going to make sure I draw as close as I can to those points. And then our second equation is also written in slope-intercept form. It just doesn't have an x value. And so what this means is that this is just a horizontal line. Just a straight horizontal line that's going to cross the y-axis at -1. You could also consider it like this, right? So our slope is 0, which means it's horizontal. And so it's going to cross right here on my graph, which makes my intersection point that spot right there, which is 4 on the x-axis and -1 on the y-axis. Okay, we'll do a couple more. For example C, I'll do this one in red. Y equals x. Doesn't have a b value. That means it's 0. So we'll put a dot right there, line right there. And then the slope is 1. So rise 1, run 1. It's going to take me all the way up there, and then all the way down here. And then for the second line, I'll do in purple. It has a y-intercept of 3 and a slope of 1/4. Rise 1, run 4. And right there is going to be my intersection point. And so that point right there is 4 on the x-axis and 4 on the y-axis. So 4, 4. Now, what's interesting is that you should be able to also check your answer, not just by graphing, but I can show you real quick. If I plug my answer in up here, I should be able to, just like I was doing in the last sections, check my answer by seeing if the x and y both work for both equations. So if y equals x, and I plug in 4 for x and 4 for y, that top equation's true, 4 equals 4. And then for the bottom equation, if I plug in 4 for x, 1/4 of 4 is 1, and of course 1 plus 3 is 4, and y was equal to 4, so that also checks out. So I can check my answer just by plugging it back in to the original equations. For example D, I'll do the top equation in green, y-intercept of -5, the slope of -1 means down 1 over 1. And then for the bottom equation, I'll do in gold. And so 1 is the y-intercept, and the slope is rise 3, run 1. Remember to turn any whole number into a fraction just by putting it over 1. And herein lies the problem with graphing. As you know from when we use substitution and elimination, you don't always get an integer answer. Sometimes it can be 0.5 or it can be a decimal answer. And so right here is our intersection, but it's kind of hard to see exactly what that is. So it looks to be between -1 and -2 on the x-axis, so we'll say maybe -1.5. And then on the y-axis, it seems to be between -3 and -4, so maybe -3.5. And so if I had to guess, I would say that's what my answer probably is. But again, that's a guess, and I don't want to have to guess when I'm trying to solve the problem here. So one disadvantage to graphing linear equations is that it's not always easy to find the exact intersection if it doesn't cross at an integer spot. So how can we be sure what the solution is? Well, we can use one of the other methods that we've learned. In this case, substitution would be the easiest way. I'm going to substitute -x minus 5 in for that y right there, since y equals -x minus 5. So -x minus 5 equals 3x plus 1. And then we can move the x's over to the right side of the equation, which would give us 4x on the right side. And we can also move the constants over to the left side by subtracting 1 to get -6. And then dividing -6 by 4 will give us -1.5 for x, which is what we thought it was, actually. It was between -1 and -2. And then to find y, I could go and plug x in for any of these equations over here. I'm going to choose the top one. -1.5 would be positive 1.5 minus 5. And 1.5 minus 5 is going to give us negative 3.5 for y. So y equals 1.5 minus 5, so y equals negative 3.5. And that's exactly what we thought it was going to be. So now we can do some examples where the equations are not written in slope-intercept form. The top one up here is an example E, so I can go ahead and do that one. Negative 7 is the y-intercept, and I barely have negative 7 on my graph here. And then I'm supposed to go down 4 over 1, but I can't do that because it would take me off the graph. So instead of going down 4 and right 1, we can go up 4 and left 1, and that'll still give us a slope of negative 4. And so that's going to be my, if I can graph this here, there we go. That's going to be my line. And then, so for the other equation, we just need to move the x over to the other side by subtracting x from both sides to get y equals negative x. And then there's a positive 2 over there. So 2 is going to be my y-intercept. And then I can go down 1 over 1 all the way through. So we go in this direction here. And then I can go up 1 and left 1, and it'll go in this direction here. And then I have my intersection point right there. And that intersection point looks to be negative 3 and 5 as my ordered point. For the next example, here we go, x minus y equals 5 is not written in slope-intercept form. So all we have to do is, again, move the x over to the other side, but that's going to give us negative y. Don't forget that y is negative, equals negative x plus 5. And I'd have to convert that into positive y, and just times everything by negative 1 equals positive x minus 5. And so my y-intercept is down here at negative 5, and the slope is 1x. So rise 1, run 1, all the way through my graph. And then for the bottom equation, it's going to take a little bit more work. We have 2y equals, we're going to move this negative 6x over to the other side. It's going to be a positive 6x minus 2. And then we're going to divide everything by 2. So y equals 3x minus 1. And so we have a y-intercept of negative 1. We have a slope of rise 3, run 1. And then down 3 and left 1. And down 3 and left 1. And we actually see our intersection point is going to be right there at the bottom of our graph. Right here. So that's negative 2 on the x-axis, and that's negative 7 on the y-axis. We can also solve story problems by graphing the system of equations. So this example says a kicker on a football team scores 1 point for making an extra point, and he scores 3 points for making a field goal. The kicker makes a total of 8 extra points and field goals in a game, and they scored 12 points. Write and solve a system of linear equations to find the total number of extra points and the total number of field goals. So for our two equations, it did say that it's 1 point for every field goal, which we'll call x, and 3 points, or 1 point for every extra point we'll call x, and 3 points for every field goal that we'll call y. So one system of equations I could write is that I get 1 point for every extra point, so 1x, or just x, plus he got 3 points for every field goal, so 3y, and it said he scored a total of 12 points in the game. It also said that the kicker made a total of 8 kicks. So if you add the extra points together, plus however many field goals that was, there should be 8 total kicks. So the top equation, the 1x, 1 point for every extra point, the 3y, 3 points for every field goal, and then you add them together, he scored 12 points in the game. The bottom equation, he made 8 kicks. So if you add them together, we get 8. So I need to convert both these to slope-intercept form. The bottom equation, we're going to slide that x, move the x over to the other side by making a negative x plus 8. So we have a y-intercept of 8 over here on our graph, and it's going to go down 1 over 1 all the way through our graph, like that. And then for the top equation, we're going to move the x over to the other side, making it a negative x as well. And then we have to divide everything by 3. And so remember that this is a negative 1x. So when I divide by 3, it's going to give me negative 1/3 x. And then 12 divided by 3 is 4. So 4 is our y-intercept. And we're going to go down 1 over 3, down 1 over 3, and down 1 over 3. So our intersection point is right here. And so x is 6, and y is 2. So I'm going to say 6 extra points. And then for y, the y stood for field goals. And so he must have made 2 field goals. So 2 field goals. And there's my ordered pair. X is 6, which stood for extra points, and y is 2, which stood for field goals. And it's important for every story problem that we label. All right, so the last thing I want to talk about today is the break-even point. And so the break-even point of a company is when the cost to run the company equals the revenue, which is the money that's brought in. So let me define these words a little bit better for us. So when I run a company, there's revenue brought in. Obviously, I'm going to make money, but it also costs money for what I'm doing. So for example, if I was running Walmart, the revenue, I'm making a ton of revenue for my Walmart. Every time I sell an item, I make money. But it also costs me money to purchase those items for sale. So maybe I purchase, Hanes t-shirts, and they cost me $5, and I turn around and sell them for $10. There was a cost, but if I sell it, there will also be a revenue. At a business like Walmart, you're also going to have costs, which are your electric bill, the cost to own the building. All your employees are going to need to be paid, and also probably have insurance. And so there's tons of costs when it comes to owning a company like that, but also a big company is going to have a ton of revenue. So if I take all the revenue and I subtract away all my costs, whatever's left over is my profit. And you can use this equation even if you are doing some sort of fundraiser, like a car wash fundraiser. My costs for the car wash fundraiser, I'm going to have to buy a bucket, right? Maybe multiple buckets. I'm going to have to buy sponges and soaps and all the stuff I want to use for my car. And then the revenue is how much money I charge per car and how much money I bring in. And so at the end of the day, if there's any money left over, that would be my profit for my fundraiser. Now, the break-even point is when the cost equals the revenue. So if I have to pay $400 to buy my supplies, and then I only make $400 in the car wash, my profit is 0. Because the cost equals the revenue, and so if you subtract them away, you're left with no profit. And that's what the break-even point is. A company does not want to break even. A company wants to make a profit. Obviously, if they break even, they'll have to close. So for this question, it says your family starts a bed and breakfast. It spends $500 fixing up a bedroom to rent, and the cost of food and utilities is $10 per night. Your family charges $60 per night to rent a bedroom. Find the break-even point. So our cost equation, it costs us $10 a night. So let's let X be the number of nights. It costs us $10 a night to be able to feed and water bill and all that stuff for the people that are staying in the bed and breakfast. And then it cost us originally $500 just to fix up the place. And that was just a one-time. So that's going to be our y-intercept. And then our revenue equation is that we are charging them $60 per night, so that would be 60x. And the break-even point is just when these equations are going to intersect. So really all we're doing is exactly what we've been doing, graphing the equation and seeing what the intersection is. So for example, or for the C equation here, which I did in red, that cost me $500. Oops. Do that in pencil here. $500 is my y-intercept, and then it charges. I have to pay $10 a night. Now, my y-axis is not counting by tens; it's counting by 50s. So I can change this 10x to, instead of being 10 over 1, I can change it to 50 over 5. That's the same as 10. And so then I would go up 50, and I would go over 5, and that would put me right here. And up 50 and another 5 would put me right there. And so this represents my cost equation. You can see my costs are going up. And that's because it's still I still have to pay for food and everything to feed the family, regardless of how many families I have. Now my revenue equation, I'm starting at 0 because it doesn't have a y-intercept value, and I'm going to rise 60 and run 1. So it's increasing at a much faster rate. Also, 60 over 1 is not on my graph, right? I can't rise 60 since it's counting by 50s. But I could rise 300 and run 5. And so I'm just trying to make it easier to graph this. 300 divided by 5 is still 60. So rise 300, run 5. Rise another 300, run 5. And so this blue equation represents my revenue. And so my revenue is increasing at a high speed. And so my break-even point is going to be right here. And that value represents the 10 nights. So x equals 10 nights. And then the y value is the dollars, right? So 10 nights, and that's at $600 on the y-axis. So what basically is that saying? If I look at the graph here, I won't start making money until this line right here. So before this point, I actually invested more into my bed and breakfast than I was earning. But as soon as I have it reserved for 11 nights or 12 nights or 13 nights, all of a sudden now my revenue equation is exceeding my cost equation. Before that point, my costs were higher than my revenue. But now my revenue will be higher than my costs. And so that's the break-even point, is when you get to 0 and when you're finally out of debt, I guess you could say. And then now everything you make will be profit. Now, we have some questions like this in our homework, so I would like to look at number 4 from the homework. It does not give you a graph to solve. So we don't have to graph these revenue cost equations in order to figure out what the break-even point is. What we can do is just use substitution. Remember, the break-even point is when cost equals revenue. So if I want the cost to equal the revenue to find my break-even point, then I want whatever the cost equals, 15x plus 150, to equal whatever my revenue equals, 45x. So I'm just using substitution because C equals R. I'm using substitution to set those two expressions equal to each other. And then I would solve for, this is 45, there we go. I would solve for x by moving the x's over to the right side by subtracting 15x from both sides. That's going to give me 30x, and then 150 on this side. And then, of course, x is going to go into 150, or 30 is going to go into 155 times. So my x value is 5. And then to find my y value, I'm going to plug it. Remember, the y value, even though there's no y value up here, these would technically both be y's, right? So it's in slope-intercept form. So I can plug 5 in for x for either of these equations. It would be probably a little bit quicker to plug in 5 for that x right here. So if I do 45 times 5 using my calculator, and you get 225, if I can write this here, 225 for the y value. And it doesn't matter if you would have plugged that into the top equation, you would have gotten the same exact value for y if you did it correctly.